Hey everyone, so in this video we're going to be covering 10 of the most important and common question types you need to know for the SAT math exam. Now, if you want 50 plus SAT math questions, we have a playlist I'll link down below. As always, try the problems on your own before watching the solution, and good luck on your exam. This one says, in the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? So they give us a quadratic equation, negative x squared plus bx minus 676 equals 0. So in order for us to solve this problem, we need to calculate what is called the discriminant. So the discriminant is what you're going to find in that quadratic formula. So that is square root of b squared minus 4ac. All right, so if you didn't know, the discriminant determines the number of solutions a function has. Or a quadratic function has. So if this value is positive, that means it has two solutions. If it is negative, then that means it has 0 solutions. And if it's equivalent to 0, that means it has one real solution. So in order for us to calculate this, we just need to know what the this part right here, the negative 4 times a times c is equivalent to, and then just find a b value that is less than that, but the greatest possible value. I'll show you how to do that. So let's first calculate negative 4 times a, we know our a value is negative 1, times c, our c value is negative 676. And this will give us a value of negative 2,704. All right. So as we talked about before, we need to know that the value of b squared has to be less than 2,704, but it has to be the greatest possible value. So what we can do is just set b squared equivalent to 2,704. Not negative 2,704 because this has to be a positive value in order to be subtracted, right? And so now we're just going to solve for b. So if we take the square root of both sides, we're going to get b is equivalent to the square root of 2,704, which is oddly equivalent to an odd number, whole number, which is equivalent to 52. Now 52 is not our final answer, because if b is equivalent to 52, our discriminant would be equal to 0 and we would have one solution. But this equation has no real solution. And so we know that b is a positive integer. So in order for b to be a positive integer, it is just the number that is below 52. So the next closest value under 52 would be 51. And so the greatest possible value for b is 51, because if we can test this, 51 squared is 2,601. And that is indeed smaller than 2,704. And so if you did the math there, you would get a negative value. And so the discriminant would have a negative value, meaning you would get no solution. And that would ultimately solve the problem. And this problem says that the circle above has a center O, the length of arc ADC, the minor arc is 5 pi, and x equals 100. What is the length of arc ABC? All right, so if we look at this, what we want to do is set up a ratio, right? So the first thing we know is that the angle x is going to be corresponding with that arc ADC. So our angle x, we can just write this on top, would be 100, right? And so it's corresponding to arc ADC, which has a length of 5 pi. And so now they want us to determine what is the length of arc ABC, right? This side right here. This side right here, right? So because we know that the circle is split up quite evenly, right? The degree value over here is going to correspond with that arc length of ABC. And so can we determine that angle? Well, we can't, because we know there's 360 degrees in a circle. And so if angle x is 100 degrees, we're left with 260 degrees, right? So this will go on top. And so now we can actually pretty easily figure out what our length of arc ABC is by just finding this corresponding value, right? So to do this, we have to do some simplification, or we can just find the factor actually, right? So from 100 to 260, that is a scale factor of 2.6x, or 2.6 times. And so we can assume that for the same thing on the denominator, to keep this ratio constant, we also have to multiply this by 2.6. And so here we can just do 5 times 2.6 pi, and that's the same thing as multiplying 5 pi by 2.6. So 5 times 2.6, that will give us 13, right? And then we can just add the pi at the bottom, or next to it. So we get 13 pi as our final answer. It says for the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? All right, so they give us, it says they give us 3 values of x. And so what we can do is actually make the function, right? Let's plot it out. So we have f of x, and so now we have to find out what the slope is. That's what the a represents because it's right in front of the x. All right, so to find that, we just want to look at the difference in between. So it's rise over run. So from negative 64 to 0, that's the increase of 64. And from 0 to 64, that's an increase of positive 64 as well. And we can see for that each positive increase of 64, so that's a change in y, our change in x is just plus 1, right? So we can determine that our slope is 64x. All right, so now we want to determine b. So b is the y-intercept. And so the y-intercept is the value you get when x is 0. Now it's not on here, but we can predict what it is. So we know that the difference between 1 and 0 is a x value of 1, right? So plus 1 here. And so we can just work backwards. So instead of adding 64, we can just subtract 64. And so here, minus 64, we'll get a value of negative 128. And so our x-intercept would be 128. So you could write this as plus negative 128, but it's the same thing. So it says, what is the value of a minus b? So our a value is 64, all right? And it's subtracting the b value. The b value is negative 128, all right? So if you subtract a negative number, we're essentially adding it. And so 64 plus 128 is just 192, so that's our final answer. This one says which expression is equivalent to 4 over 4x minus 5 minus 1 over x plus 1. So we have a bunch of answer choices here, and the first thing we want to do to simplify this for equivalent expressions is just get the same denominator, right? That way it's easier to work with, and we can actually do some arithmetic when it comes to it. So we see here that in the first term, we have 4x minus 5 at the denominator, and then for the second term, it is x plus 1. So we can do pretty easily is just find a common multiple between these two terms, and we can just do that by multiplying 4x minus 5 by x plus 1, and then vice versa, multiply x plus 1 by 4x minus 5. And by doing that, we also have to do the same thing to the numerator. So we'll see how that works. So we have 4 over 4x minus 5, and we will be multiplying this by x plus 1 over x plus 1. You can see how that in reality that we're just changing both the top and bottom of the fraction, because x plus 1 over x plus 1 is really just 1. And so here we'll get 4x plus 4 over 4x minus 5 times x plus 1. And so now we'll just want to do the same thing to the other side. So here we're going to have this term right here, 1 over x plus 1. We're going to be multiplying this by 4x minus 5 over 4x minus 5. And so therefore we will get 4x minus 5 over, and then we get x plus 1. So that's just going to be the same thing, 4x minus 5, and then x plus 5. And so now we can also just look at this entire thing over each other, right? So we have 4x plus 4 minus 4x minus 5, but they have the same denominator. So in reality, this can just be rewritten as 4x plus 4 minus 4x minus 5 over all of this. So let's write it out again. Kind of tedious, but you gotta do what you gotta do. You'll see pretty interestingly is that some of the answer choices have this denominator. So we know we're on the right track here, right? So let's just evaluate the top part, right? So with 4x minus 4x, those two are going to cancel, right? So that's just gonna be 0. But now in our case, we have 4 minus negative 5. So we're really just adding 5 to 4. That's gonna be 9. So you have 9 on top, and then 4x minus 5. Really messy, but whatever. X plus 1. And so we have our equivalent expression right here. And we can see that actually matches up with answer choice D, and therefore that is our answer. So it says in the xy plane, a parabola has a vertex of 9, negative 14. It intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus c plus c? A plus b plus c. Okay, yeah. So definitely a lot of constants. But so first off, we see that it has a vertex. It gives us the coordinates of the vertex, and then it says that if it's written in the form of just y equals ax squared plus bx plus c, the standard quadratic form. So this is a screaming vertex form, right? Because we need to convert what we know, the information we know with the actual values, which is the vertex, into that quadratic. So here's how we would do it. So we have that vertex form. So vertex form would be y equals a times x minus h squared plus k, all right? So in our case, we would have y equals, we don't know what the a value is, so we'll just keep it as that. X is just x, and then our h value, so 9 is our h value, and then negative 14 is our k value. So 9 here goes here, so minus 9 squared, and then plus negative 14 is just negative 14. All right, so now that we have this, what we want to do is just expand it out. We don't have the a value, but that's okay, because you'll see in a second, it actually doesn't matter. So y equals a, and then x minus 9 squared would just be ax squared. I actually want to put this in the parentheses. So x squared minus 18x plus 81. And then we have the negative 14 on the outside. But now notice how the a times x minus h squared, the a is attached to it. So then we need to distribute the a again to each of these terms. So then we get y equals ax squared minus 18 ax. And yeah, guys, make sure you try the problems on your own, all right? But yeah, 81a. And then we add, and then we add negative 14 at the end. All right, so now we have our quadratic equation, right? But the problem is we don't know what a is. So the problem is if we don't find a, it doesn't really work out. But do we need to find a really? Well, you'll see in a second. So first off, let's label each part of our equation here. So the ax squared, that is our a value. This negative 18ax, that's our b value in this equation. And then the 81a minus 14 is our c value. So here's the thing, right? We can put everything in terms of a and just negate the x squared, the x, those values, because those don't actually account for the sum, right? We're only looking at the value of a plus b plus c. So it doesn't matter if it's 2x squared plus 3x, 2 plus 3 is 5. So what we can do is write this as in terms of a. So a would just be a, right? Because we're just canceling out the x squared, we don't care about it. So a is a, now we have to write b. So now we want to add the b value, which is negative 18a, right? So really we're subtracting negative 18, but there we go. And now we want to add the c value. Now our c value is this entire thing, and there's no x value, so we can just write it in terms of the entire thing. So there we go. We get this long equation. If we simplify this down, what we get is 64a minus 14. All right. So this right here, 64 minus 14, this represents the sum of A plus B plus C. All right. So now how do we determine what could be a possible value, right? Like how do we actually get our answer choices? Well, we actually have to go back into the question and look at what was given. So it says that it's a parabola with a vertex of 9, negative 14. It says it intersects the x-axis at 2 points. All right. So if we draw this out, this is very helpful. Draw this out. The vertex 9, negative 14 is going to be in quadrant 4. So it'd be like down here somewhere, right? So if it intersects the x-axis at 2 points, that means the parabola has to open upwards. And that means the A value must be positive, right? So if it intersects, it can't be like this, right? It can't be like this because the vertex then would be up here, which makes no sense. So what it has to look like is like something like this, right? Boom. Very straight, curvy parabola, but whatever. So now what we want to do is just set this equation right here equal to each of our answer choices. You'll see something very interesting. So this is going to be a very long process because I'm using my mouse, but yeah. So we set this equal to 23. And yeah, feel free to skip ahead if you don't really want to see me write all this out. But I just kind of have to like prove my point. But yeah. I appreciate any of you who keep watching for the YouTube algorithm. All right, negative 14. I'm doing the best I can right now. I'm trying to write as fast as I can, but you know, there's limitations. Negative 14. Okay, that is just straight up messy, but okay. So now we know that in order for our A plus B plus C to like work out, the A value has to be positive. So we'll just find the A value for each of these equations and see if it works out, right? So we'll just work from top to bottom. Boom, boom. So first off, for our first equation, if we just do some simple algebra, we can add 14 on both sides. But negative 23 plus 14, that's going to give us a negative value. So if we have a negative value and then you isolate for A, a negative value over 64 is going to give you a negative value for A. So this cannot be our answer because it'll be negative. It's the same case with the very next one, right? Negative 19 plus 14 is negative 5. Negative 5 over 64 is negative, so it can't be this one. And then right here, it's a very interesting case. You have negative 14 and negative 14 on both sides. So if you add positive 14 on the left side, you'll get 0. 0 over 64, that's not a positive value, right? You get 0. So it can't be this one either. And so our last one, very cool. You add 14 on both sides, and guess what? You get a positive value, right? You get 2 right here, and then you get 64A. And guess what? If you isolate for A would give you 2 over 64, and 2 over 64 is a positive value, and therefore it satisfies this up here, it satisfies everything else, and this is our correct answer. So our answer choice is D. During a month, Morgan ran R miles at 5 miles per hour and biked B miles at 10 miles per hour. She ran and biked a total of 200 miles that month, and she biked for twice as many hours as she ran, was the total number of miles that Morgan biked during the month. So there's a couple ways you can approach this. But I think the simplest way is honestly just through ratios and systems of equations. So first off, we have 200 miles that she runs in total. And we can set this equal to R plus T, because that's the total mileage that she ran, right? The number of miles she runs and the number of miles that she bikes. So now we want to set up a system. So in our case, we should have a variable. We'll call this X. So X in our case, let's say, is the total number of hours that she spends on the activity. So in our case for running, we can just say 5x, right? So in our case, if x, let's say she spent 2 hours doing that activity. If she spent 2 hours running, it would be 2 times 5. And so that would check out. So if she ran for 2 hours at a rate of 5 miles per hour, guess what? She's going to run a total of 10 miles as her distance. Now, if we zoom in now for biking, that's a different story. Now, why? Well, first off, her rate is different, right? So instead of going at 5 miles per hour, she's going at 10 miles per hour. So it really doesn't matter whether she's running or biking, but it's only the speed that changes. And also, if you have an external variable, which in our case we do, because she says that she biked for twice as many hours as she ran, right? So we can't just write 10x here because we know that she biked for twice as many hours as she ran. And so we can put a 2 on the outside here, multiplied by the rate of 10x. So 10x is just the amount of time, or rather x is the amount of time she just spends in activity. So watch what happens. So we have 5x plus 2 times 10x. So this becomes 20x. And this is 5x. So this becomes 25x equals 200, right? And so if we solve for x here, we get 8. So 8 doesn't have a really meaning in this problem, but if we plug this in to each of our rates, we can actually find the answer. Now why? Well, because we can plug this back into the 5x here. So we know that she runs 5 miles per hour. So if she's doing x activity for 8 hours, that's going to give us 8. So that's 40. That's 40 miles. And we know in total, she ran and biked a total of 200 miles. And so 200, boom, boom, minus 40 is 160 miles. And so that is our final answer. And there's another way you can check. Using this equation right here, 20x. So 20 times 8, right? That value of 8. And guess what? That also gets us 160 miles. And so our final answer is D. The function f is defined as f of x equals negative 8 times 2 to the power of x plus 22. What is the x-intercept of the line y equals f of x in the xy plane? All right, so first off, the number is probably jumping out at you, the plus 22, but don't fall into this trap. You know, there's always that answer choice that they want you to pick, but it's really just a trick answer. So instead of jumping to conclusions, seeing this plus 22, it's saying, this, everything else here is being multiplied and it's dependent on x. But something you'll notice here is that the y-intercept is the value you get when x is 0, right? So if we look at this more closely, 2 to the power of 0 is really just 1, right? And so 1 is going to be multiplied by negative 8. So 1 times negative 8. And that gives us negative 8. So in reality, we have negative 8 plus 22. And negative 8 plus 22 is going to give us 14. All right. So 14 here is going to be our y output when x is 0. And therefore, our answer choice is going to be A. Given equation relates the variables x and y. For what value of x does the value of y reach a minimum? So here, first off, this is a quadratic equation, right? And it wants us to find the value of x when y reaches its minimum. We can see that the positive coefficient in front of x squared is positive, and therefore it's going to open up that parabola. And so it makes sense that we're looking for the minimum, because the minimum here is going to be that vertex, right? And so if we're looking for the x value of the vertex, that's just the x coordinate of the vertex, and therefore we can actually use the following equation. It's going to be negative b over 2a, right? This is a part of the quadratic formula, so you don't have to really memorize this if you have the quadratic formula down. But yeah, let's just solve for it now because we have our corresponding values, right? We know that our b value is going to be represented by negative 14, so let's just label this as b. And then our a value is going to be positive 1, so let's label this a. So then our b value will be negative 14, but this is negative b, and so we have negative 14. There we go. And then for the bottom part, let's change to red. We know a is just going to be 1, so that should be 2 times 1 is 2. And so therefore, we will get the following. We will get, change to green, we will get 14, right? Because a negative of a negative is going to be positive over 2. And so 14 over 2 is going to be 7. And so 7 will be our x coordinate of the vertex. And we know the vertex here represents the minimum of where y will reach its minimum. And therefore, x will equal 7. In the given system of equations, h is a constant. If the system has no solution, what is the value of h? All right, so if the system has no solution, that means the lines will never intersect. And we can see here we're dealing with linear lines. And so linear lines that never intersect are going to be parallel lines. And we know parallel lines have the same slope and different y-intercept. So in order to do that and find the corresponding values for the constant of h, what we need to do is first put these equations into slope-intercept form. So the top one right here, what we can do here is add 9y to both sides, and then we want to subtract 5 from both sides, just so we can isolate for y. So we have 18y equals 4x minus 5. And now for slope-intercept form, this will just simplify. We divide both sides by 18. So y will be equivalent to 4 18 x minus 5 over 18. All right, so this is our equation, right? That means what we need to do is get this equation, the second equation right here, to have the exact same slope of 4 over 18, but a different y-intercept. So let's see if we can do that. So we have hy equals 2 plus 4x. So let's zoom in on this slope, right? The current slope is 4, has a value of 4. Let's just ignore the x for now. So the current value of 4 is much more different versus the slope that we want, which is 4 over 18. So how do we go from 4 to 4 over 18? Well, we can do this by just multiplying 4 by 1/18. And therefore, that will give us 4 over 18. And so how do we multiply 4 by 1 over 18th? Well, that's the same thing as dividing 4 by 18, right? And we know that in order to divide this 4x, the h value will have to represent that, right? So let's say h was 18, then 4 would be divided by 18 when you isolate for y. So I'll show you how this works. So if h was 18, then we get 18y equals 2 plus 4x, right? And so now when we isolate for the y value, divide both sides by 18, we get y equals 2 over 18 is 1/9 plus 4 over 18 x. And so now we have our two equations, right? We have this equation and this equation. We can clearly see that they have the same slope of 4 over 18, right? But they have different y-intercepts as we wanted before. So this one has a y-intercept of negative 5 over 18. This one has a positive y-intercept of 1/9. This is messy. But because of that, we know the constant h is going to be the letter d, 18. Figure AC equals CD, okay? And the measure of angle EBC is 45 degrees, so let's label that. Boom. Okay, and the measure of angle ACD is 104 degrees. What is the value of x in degrees? So the value of angle AEB, that's what we're trying to find. So the angle of AEB. Okay, so how I like to approach, just geometry problems in general when you're trying to find an angle is just, don't try and take it in all at once. Just take it step by step, break it down, see what angles you can find, see what theorems you can implement, and eventually, you never know, you might find the answer from that. So first off, they tell us that AC equals CD. So this triangle right here, triangle ADC, this is a isosceles triangle, right? Because these two side lengths are equal, then we know that these angles here, angle D and angle A, are going to be equal to each other. Because there's only 180 degrees in a triangle, and we know angle ACD is 104. I should add units. Boom, boom. So that gives us 76 degrees between those two angles. And so we can divide that in half, and we get 38 degrees. So we know each of these angles, so angle A is 38 degrees, and angle B is also 38 degrees. Okay, so that's one step of the puzzle. So how exactly can we find angle this x, right? So one way I'm looking at it right now is it's on this line right here, and we can use what's called the supplementary angles, right? Because two angles on a straight line will have to equal 180 degrees. So if you find this angle right here, angle DEB, whatever that is, if we find that value, then we can just subtract 180 minus that value, and then we get whatever x is going to be. So is there a way to find angle DEB? Well, it's actually pretty interesting because they gave us the measure of EBC, this angle up here, and we just figured out the angle of BDE. And so these two angles make up a portion of this triangle, right? So it's this triangle right here. Boom, boom, boom. Oops. This triangle, all right? So we know there is, let me just switch back, there is 180 degrees in a triangle. So if we found two of the angles, 45 degrees and also 38 degrees, then we can find the last value. And this last value, let's do some quick maths. I think that is 97 degrees. Okay, so angle E is 97 degrees. All right. All right, so as we said before, now we can use supplementary angles. So we know these two angles, this angle we just found here, 97 degrees, and angle X, together they will have to equal, so 97 degrees plus X, whatever that is in degrees, has to equal 180 degrees. And so we can do some simple maths. 83 is our final answer. So the value of X would be 83 degrees. And I think they want you to represent it as just the value without the degrees because they already state the degrees here. And so if you're really finding X, the actual answer is just 83. So yeah, there you go. That's the answer. And thank you guys for watching. I hope you learned something.